Hello everyone, and welcome to another episode of Math and Silly Hats. We're continuing our series on exponent laws today, and today we'll be talking about the power of a fraction rule. Let's get into it. All right, so as you see here, when we have a power of a fraction, again, things you hate are fractions and exponents. So we are combining them this time. If you take a power of a fraction, you're going to just apply the exponent to both the numerator and denominator, which is very similar to the power of a power or the power of a product that we covered last time when you had multiple things inside of parentheses and you had to distribute that exponent to each of the variables as well as the coefficient. So you might have a problem like, pay no heed to the scary, x squared over y to the third. If you take that whole darn thing to the fourth power, what'll end up happening is that fourth power will kind of distribute to each of the exponents inside of the parentheses in both the numerator and denominator, and it'll work very similar to the power of a power rule. So this would become x to the 2 times 4 over y to the 3 times 4. You can see where that 4 came from. It was just the exponent applied to everything inside of the parentheses. So we can simplify this as x to the 2 times 4 is just x to the 8th. Y to the 3 times 4 is just y to the 12th. And we're done. Let's cover a simple example of this. A simple example might involve just a coefficient, a variable, and then a different variable. You have to be careful if there's multiple variables or coefficients in the numerator or denominator, this exponent will be applied to each of them. So that to the second power is going to be applied to the coefficient here. Power of a power, we just multiply. Power of a power, we just multiply. We just multiply. So you can see my second power got applied to the coefficient, the x, and the y. Simplify, 2 squared is just 4. X to the 3 times 2 is x to the 6th. Y to the 2 times 2 is y to the 4th. Easy peasy lemon squeezy. Of course, if you're asked to write this not being a fraction, you could also write this as equals 4x to the 6th. And remember, the negative exponent law says that when we have a base to a negative power, we can move it to the other part of a fraction, but we have a base to the positive power. Well, just think of it as a negative power, because negative power is positive power, right? So we can put it in the numerator as a negative power. Or conversely, if we had y to the negative 4th, it would go to the denominator and become positive. So if you're asked to represent this without using fractions, and you are allowed to use negative exponents, it can be written this way. So this is not necessary, but some state tests and your teachers will ask you to do so. Let's deal with a medium difficulty problem. Medium difficulty problem, you may see repeated variables or coefficients in the numerator and denominator. So let's say we have negative 2, x to the 3, y to the 2. Let's get that negative next to that 2. Divided by 4, x, y to the 3rd. All of that to the second power. I like to always draw little lines, kind of like distribution, to make sure I hit all of the things I need to with this second power. So I need to make sure I get to both coefficients, both x's and both y's. So negative 2 squared, x to the 3 squared is going to be x to the 3 times 2. Y to the 2 squared is going to be y to the 2 times 2. 4 squared. X to the 1 times 2. Remember that x just by itself is the same as x to the first power. And y to the 3 times 2. So did we get all the 2's in there? Well, we got negative 2 squared. We got x to the 3rd squared. Got y squared squared. 4 squared. X squared. And y to the 3 squared. Let's simplify. So negative 2 squared is 4. X to the 3 times 2 is x to the 6th. y to the 2 times 2 is y to the 4th. I'm going to leave 4 squared for now because I can blatantly see a 4 in the numerator and denominator. X to the 1 times 2 is x squared, and y to the 3 times 2 is y to the 6th. Now I see a lot that's repeated in the numerator and denominator. Let me put a quick 4 to the first power up here so I can show you why I'm doing what I'm doing. Now from the quotient rule, we know that when we have the same base in the numerator and denominator, the result will be the numerator minus the denominator. So same base with to the power of the numerator minus the denominator. X to the 6 divided by x to the 2 is going to be x to the 6 minus 2. Y to the 4 divided by y to the 6 is going to be y to the 4 minus 6. I'm going to get rid of this full fraction nonsense. So 4 to the 1 minus 2 is 4 to the negative 1. 6 minus 2 is 4. 4 minus 6 is negative 2. So this is our solution if we're allowed to use negative exponents. If we're not, we can use the negative exponent laws to say we can make this whole thing a fraction. And whenever we have a negative exponent, we're going to change its place in the fraction. So we're going to take this 4 to the negative 1, put it in the denominator, make it positive. This y to the negative 2, put it in the denominator, make it positive. So our solution will either be 4 to the negative 1, x to the 4th, y to the negative 2, or if we're asked to only use positive exponents, x to the 4th, 4 to the 1st, or just 4y squared. Let's do a difficult one where we might not just see repeated exponents, but we might see nested things. All right, so let's work from the inside out. Now, before we actually distribute, we can simplify this. Let's do that first. Let's realize that we have a power of 2 in the numerator and denominator. Let's cancel a factor of 2 in the numerator and denominator. We have an x in the denominator and numerator. Now this will be a bit easier. So all I simply did was said there's a power of 2 in 2. There's a power of 2 in 4. And there's certainly an x down here and an x in the numerator. So we just had x, y over 2. Now let's make sure that that 2 on the outside gets to the x, the y, and the number. So this will be x squared y squared over 2 squared. That'll get rid of the first exponent. Then we can do that again. Make sure this 3 gets to all of the x's, y's, and coefficients. So x to the 2nd to the 3rd is x to the 2 times 3. Y to the 2nd to the 3rd is y to the 2 times 3. 2 to the 2nd to the 3rd is 2 to the 2 times 3. And then we just have to simplify. 2 times 3 is 6. 2 times 3 is 6. 2 times 3 is 6. And we don't have any repeated variables or coefficients in our solution, so we are done. Hopefully this explanation and examples have been helpful, and you can now solve power of a fraction problems on your own. Have a great day, everybody. Bye-bye!